To simplify these expressions with polynomials, we need to factor the numerators and denominators first. Here, since we have a coefficient of 1, we're really looking for two numbers that will fit into this pattern. So we have a y plus or minus one number and times a y plus or minus a second number, so that the first number is 1 times 15. So the two numbers multiply together to make 15 and add to 8. So those numbers would be positive 3 and positive 5. If you wanted to check this by foiling, you'd have y squared plus 5y plus 3y, that's plus 8y, plus 3 times 5, or plus 15. Then we would do the same thing here. Since I have a coefficient of 1, I'm really looking for two factors, including y, as binomials that are going to be structured like this. And I'm looking for two numbers that multiply to 1 times 18 and add to positive 9. So those would be positive 3 and positive 6. That would be y squared plus 6y plus 3y, that's plus 9y, plus 3 times plus 6 would be plus 18. Now, once I factored each of these, I reveal that I have a factor of y plus 3 divided by y plus 3, and y plus 3 goes into y plus 3 once in each case. So all I'm really left with here is y plus 5 over y plus 6. We have to leave it like this. If you want to put it in parentheses, that's a good way to remember that we cannot just cancel the y's out here because they are terms. We can only cancel factors. So the y would need to be in each of these cases in order for us to eliminate it. Now we'll look at another example. In this case, since we have a 4-term polynomial, we can try to factor it by grouping. So I'm going to factor this numerator by breaking up the two sides of it into pairs. So I'm just factoring the numerator now. I'll factor an x out of both of these. So this is x times x minus y, because x times x is x squared. X times negative y is negative xy. I'm going to look for this factor to repeat itself on this side. I always bring that sign straight down. I have a positive 5 and a negative 5, so I'll factor a 5 out. That's going to get me the same x minus y that was repeated over here. Plus 5 times x is plus 5x. Plus 5 times negative y is negative 5y, so this checks out. I have a repeated factor, so it can come down. And I also have these other pieces that are multiplied by the repeated factor, so they can come down as well. So now I'll have my numerator is factored as x plus 5 times x minus y. My denominator here, I have an x squared plus a 5x, so I can factor an x out of here. That would be an x times x plus 5, because x times x is x squared, and x times plus 5 is plus 5x. I have a factor of x plus 5 here in the numerator, and a factor of x plus 5 in the denominator, so those divided by themselves equal 1, and that would leave me with x minus y over x. Remembering that this x minus y is a binomial, so it is protected. I can't just cancel these x's out. X would need to be a factor of both of these terms, and it is only a factor of the first term. So in each of these, they may look like you can just cancel terms. You can never cancel terms. You have to factor first, and then you can cancel factors in each of these situations.